This lesson deals with Supplemental Problem 2.9. You can find this problem in the ECE302 ebook in the Chapter 2 Supplemental Problems, starting on page 20. Suppose that we have an element, I'll call it X. If you plot the voltage across it and the current through it, it has this nonlinear shape. Now, it's very common in electronics to get new components, new ICs. We don't have any equations for them yet. They may be developed eventually, but we can go to lab and take some measurements, and then based on that, we can figure out what's going to happen when we put that element in a circuit. Let's do that here. Suppose that I stick this element X in this circuit with two 200 ohm resistors and a 5 milliamp current source. Suppose I want to find the voltage V sub A and the current I sub B. Let's use a load line analysis technique, since we don't have an equation for this curve, to solve for that. Back in the Chapter 2 notes, we showed that you could find the X and Y intercept pretty easily by finding the Thevenin voltage and the Norton current. That's a lot simpler than writing a series of equations, so let's try that. Let's find the open circuit voltage by removing the element, solving for this voltage across here, which also is the Thevenin voltage. With this being an open circuit, there's no current here, so the voltage across here is 0. And then if this is an open circuit, all this current goes into here and creates a drop of 200 times 5 milliamps, which is equal to 1 volt. 1 volt minus 0 would be the x-intercept. Again, it's not the answer, which is simply one point on our load line. We can find the y-intercept by finding the Norton current, or the short circuit current. So we'll replace the element by a short circuit. We're going to solve for the current in the short circuit. Get a current divider. If I want the current in this resistor, it'll be the other resistor over the sum of the two times the current of 5 milliamps. And that's half of that, so it's 2.5 milliamps. My y-intercept is 2.5 milliamps. That's this point right here. And my x-intercept is 1 volt, and so I'm going to draw a straight line. And this is the solution. I took a ruler. I tried to measure this as accurately as I could. It was about 0.375 volts and about 1.6 milliamps. Go back to my schematic and put those values in. There's the 0.375 volts across it, and the current through it is 1.6 milliamps. Solving for the current in this resistor is one of my unknowns, and of course that's equal to I sub x, which is 1.6 milliamps. Then to solve for the voltage across here, let's solve for the current and then multiply it by the resistance. I have 5 milliamps entering, and I've got a minus 1.6 milliamps entering, and that equals what's leaving, which would be the difference of those two, or 3.4 milliamps. If you multiply that by 200, you get 680 millivolts. This is approximate. This is not exactly what the voltage and current is, but pretty close. That's the best we can do with a graphical analysis technique. And this is Supplemental Problem 2.9.